All right, let's just jump right in. We usually think of failure as this terrible thing, right? Something to avoid at all costs, a sign that we messed up. But what if that's the completely wrong way to look at it? In this explainer, we're going to completely reframe how we think about failure. We're going to stop seeing it as an enemy to be defeated and start treating it as, well, as an inevitable force we can understand, manage, and even design our systems around.
This is the fundamental truth we have to start with. Just let that sink in for a second. Every single complex system, whether it's a giant cloud platform, the power grid, or even an ecosystem in nature, will fail. Eventually. And look, that's not being pessimistic, it's just being realistic. It's not a sign that engineers were careless, it's a direct consequence of complexity itself.
I mean, it just makes sense, right? The more moving parts and interconnected pieces a system has, the more ways it can break. It's just a game of numbers. So if we accept that failure is a guarantee, then trying to build a perfect, unbreakable system, that's just a fool's errand. The real goal has to be something else, something a whole lot smarter. And this is the pivot. This is the mindset shift that changes the entire game. We stop obsessing over preventing every single possible failure, and we start focusing on how quickly, how safely, and how gracefully we can recover when, not if, that failure happens. That, right there, is the heart and soul of resilience. Now, to really get our heads around this, we need to draw a sharp line between two ideas that get thrown around and mixed up all the time: reliability and resilience. Seriously, understanding this difference is the key to building systems that can actually survive in the messy real world.
So here's the key difference. Think of it this way. Reliability is all about preventing failure. It's focused on uptime, on keeping promises over a long period. It's trying to make the time between failures as long as humanly possible. Resilience, on the other hand, starts with the assumption that failure has already happened or is happening right now. Its only goal is to limit the blast radius and get back to a working state. So reliability is about staying up. Resilience is about getting back up.
You know, we have this mental image of failure, probably from the movies, where a system just blows up, a big, cartoonish explosion, and everything just stops working. But in the real world, that's rarely how it goes down. Most failures are way more subtle. They're degradations, a spike in latency that makes things feel sluggish, errors that only affect a small percentage of users, one feature being down. They're not explosions, they're cracks and slowdowns. And that leads to the million-dollar question, doesn't it? If most failures start out as these small, manageable problems, how in the world do we end up with those massive front-page news outages? Well, the answer lies in a super dangerous domino effect called a cascading failure. And this is a perfect illustration of how that happens. It all starts with one small component having a partial outage. But the other services, they don't know it's struggling. They just see a request fail, so what do? They try again and again, aggressively. This flood of retries is like shouting at someone who's already overwhelmed. It swamps the component that was already struggling and all of its dependencies. And just like that, a small, contained problem has cascaded into a total system-wide outage. Breaking that chain reaction is what resilience is all about. So, how do we actually break that cascade? How do we build for recovery? Well, thankfully, engineers have come up with a really powerful set of design patterns. Think of it as a toolkit for building resilience. Let's open it up and walk through the core tools that every resilient system needs. Okay, but before we start pulling out the tools, we have to agree on the ground rules. Real resilience isn't about some hero engineer waking up at 3 a.m., chugging coffee, and saving the day. That just doesn't scale. Instead, recovery has to be a first-class feature of the system itself. It has to be automated. It has to be fast to minimize the impact on users. It has to be safe, so our fix doesn't accidentally make things worse. And it has to be repeatable, so it works the same way every single time, without any guesswork. Our first tool is the humble timeout. It sounds so simple, but it is unbelievably important. Why? Because waiting forever for a response is a type of failure. A system that's just stuck waiting is a broken system. A timeout puts a hard limit on that. It says, look, I'm going to wait for 2 seconds and not a millisecond longer. This one simple rule stops a single slow component from dragging everything else down with it. Next up, retries. You know, sometimes a failure is just a temporary glitch in the network, and trying again will work just fine. But like we saw, dumb, relentless retries can kill a system. So we do it smartly. Smart retries use strategies like exponential backoff, which is a fancy way of saying we wait a little bit longer between each attempt, and they use jitter, which adds a tiny bit of randomness to that wait time. This prevents all the retries from hitting at the exact same moment like a thundering herd, giving the struggling system a chance to catch its breath.
Oh, this one's a personal favorite. It works just like the circuit breaker in your house that trips to prevent an electrical fire. A software circuit breaker watches for failures, and if it sees too many coming from one service, it trips. It just stops sending requests to that service for a little while. This is brilliant because it gives the failing system a chance to recover. Sometimes the kindest, safest thing you can do for a system that's on fire is to just leave it alone.
The metaphor here is just perfect. On a big ship, bulkheads are the walls that create separate, watertight compartments. If one compartment gets a hole and starts flooding, the walls contain the damage, and the rest of the ship stays afloat. In software, this pattern does the same thing by isolating resources, like pools of connections or threads. That way, a failure in one non-critical feature can't hog all the resources and sink the entire application. The whole philosophy here is incredibly simple. Partial service is always better than no service. When a system is under a lot of stress, it can gracefully degrade by temporarily switching off the non-essential stuff. So maybe the fancy personalized recommendation engine goes offline for a bit, but customers can still search for products and, most importantly, buy them. You preserve the core function of the business, which is way, way better than just showing everyone a big, scary error page. Okay, so we've got the technical patterns, we've got our toolkit, but here's the thing. Having the best tools in the world doesn't matter if you don't have the right organizational culture to support them. True, deep resilience goes way beyond the code and gets into the mindset of the people who build and operate these systems every day. So what does this culture look like in practice? Well, resilient organizations don't just sit around hoping for the best. They actively prepare for failure. They build things like automated failover to handle server problems without anyone touching a keyboard. They run game days where they simulate outages to practice their response. Some even do chaos engineering, where they intentionally break things in production in a controlled way to find weaknesses. And crucially, after something does go wrong, they do blameless postmortems to learn from it. And that idea of a blameless postmortem leads to this really deep insight. A blameless culture isn't about finding a person to point a finger at. It's about understanding how the system, the technology, the processes, the people, all of it, allowed the failure to happen. This creates an incredible feedback loop. By building processes for learning, the whole organization gets better. Improvement becomes a property of the system itself, not just the heroic effort of one person. Now, let's be real. Doing all of this costs something. It takes extra infrastructure, it makes the code more complex, and it demands serious testing. But this slide, it just delivers the punchline, doesn't it? Resilience isn't an expense, it's an investment. And you have a choice. You can pay for it up front, with time and deliberate engineering, or you can pay for its absence later, with emergency outages, lost revenue, and angry customers. But one way or another, you will pay. And that really brings us to the final core idea. We often think of strength as being rigid, unbending, unbreakable. But in the world of complex systems, that's a recipe for a catastrophic shatter. True resilience isn't the brute strength to resist failure. It's the flexibility to bend without breaking, to absorb shock. And most importantly, it's the ability to always return ready for whatever comes next.